schoolwork to this Miro.
He's given me multiple. It's because he says this homework is the preparation for my final exam. Right? So he's given me like many different topics. There's vectors. There's differentiation integration. There's one for binomial theorem and circles.
Sure.
One remainder factor theorem and partial fraction. And then the last is trigo.
Okay, so it's very comprehensive, which is good.
Yeah. So he's given me like what's this? 1, 2, 3, 6 pieces of paper. This is the first one.
Actually, what you can actually do is instead of uploading this picture, if you get it into a PDF, like PDF of all the pages, then you can actually upload that the PDF into this Miro whiteboard also.
Oh, wait. Can we open the PDFs pages separately?
In fact, okay, let me just demo to you how it works. So I just upload any PDF for you to take a look how it works first.
Okay.
So, okay, example, this is the one. Can you see the PDF here?
Yeah.
Okay, in fact, this PDF, can you see there are 2 pages, 1 of 2. So I can click on this, then you probably can see the page 2.
Oh.
So in a way, you can upload the PDF like maybe 5 pages, multiple pages. You can just flip through the pages, just right here on the whiteboard.
Okay.
Alright, so this is just a demo how you can actually upload a PDF. Alright.
Okay.
So I delete the PDF. Okay, so let's look at this first. You know how to get the physical copy into PDF, right?
Yeah.
Just scan or take picture, then somehow compound them together and make it into PDF or something like that. Okay?
Yeah.
Okay, good. So yes, let's try question 3. Question 3. This is more interesting. Yeah, do it on the right hand side.
Okay.
So do it somewhere here. Hold on, let me go and grab a drink while you are doing it. Mẹ mày một con số mày à? Đó, đó. How do you get a gradient 6 over -5?
Cause they give they give the vector AB -5 6. So 6 is the rise.
Yeah.
-5 is the run.
Okay, so then you have this negative. Wait. So it's to the left -5 up. Oh, okay. So if you construct this out, right? You construct this vector AB equals to -5 and 6 out, right? So this is what you should get. Okay? So in a way, for this, how to find the gradient is yeah, rise over run. Okay?
Okay.
So the rise is 6, the run is -5. This is yes. Okay, good. You know, I start to realize, right? For Miro, for this Miro, this app, I think it's a very good collaborative app.
Yeah.
So like you can be, let's say like you can be working on this gradient. So maybe I'm not so fast to understand how do you get the gradient. I can actually somehow just verify just on the side here.
Yeah.
Then at the end of the day, then we can actually combine our work, right?
Yeah.
So it's a very good collaborative tool. So you have a simultaneous equations.
Yeah.
Yeah. Looks good. Okay, so it looks like this question poses no challenge to you.
uh,
So, last part E. Can I ask what this
the allowance for
what this
question
is for?
4, I had to draw that because I couldn't see.
Oh, okay. Okay, pretty good.
Wait, should I draw this out? The A B C D.
Mm. So if AD AD has a multiple of BC, so it means AD is parallel to BC.
Yeah, but it's not a parallelogram because it's twice the. Oh, it's a trapezium.
Yeah. So just um, so it cannot be a parallelogram. So then it has to be a trapezium.
Okay.
Yeah. Okay, good. So okay. So for the three questions, for the three questions here, right? Uh, I don't see they ask you to find the ratio of the area ratio. There is no such question here. Can you just get one
That was
question?
question 1, but I feel like question 1 was kind of easy. I mean, I can.
Yeah, but did they ask you for the question one? Oh, okay, okay, okay. So which is not display here, lah.
No, it's not.
Okay, yeah, okay, okay, okay. Okay, it's okay. So let me just give you one because okay, let me just upload this. Hold on, let me quickly upload. Okay, let me just upload. So it's under this box and it's the sharing folder and this. Alright, so I have uploaded the PDF, which is your assignment. Okay, let me just you just pen it down lah, huh? So you get to so just okay, good. So let's try. Let me see how many pages. Wow, 3 pages. So let me flip to page 2 and see. Okay, page 2. Okay, then page 3. Alright, okay, good. So let's go to page 1. Let me go back to page 1. And probably, yeah, let's try out it. This one. And then you can do it somewhere. How do I move this thing? Never mind, you continue. You just do wherever you want to do. Oh, here. Probably you want to do it here.
Wait.
Within this.
Which question? I do question 8.
Question 8, page 1. Question 8.
Oh, because there's another question 8 on page 3 or 2.
Alright. I have circled the question already. Then probably you want to do it like over here, the frame 2 here.
Okay. Yeah, if you circle the thing, right, if you go to the next page, the circle is still there, so it looks like the circle's in a random spot.
Hold on, huh? Okay, come. Okay. I just collected the parcel.
Okay.
And actually, you know what? Actually, there is an app for. I mean, there is this app for this Miro.
Oh, like.
So in a way, you download this Miro app, and then let's say I also install. I have installed the Miro app on my computer already, or you can install it on your iPad or mobile device. So, in fact, we just need to use Miro, and then we can be working on the same stuff on this same whiteboard, and then but there is no communication feature for the Miro app. So what you can do is you probably can use the video call or the FaceTime feature on your phone. Then you just use FaceTime together with this Miro app together, then you get to have this experience. Okay, what we are using right now is Google Meet plus Miro, right? But Google Meet actually act as a FaceTime feature, right?
Yeah.
So in a way, if for people who have downloaded the Miro app, right, they can actually use Google Meet, and then they can use Zoom, they can use any FaceTime, any FaceTime app also. Because FaceTime, I don't think for FaceTime, I don't think it's time limited. For Zoom, it is, and Google Meet, it is not. So yeah. So just add a wavy line below to tell it's a vector instead of algebra. Yes. Yeah, plus is always good. So these two, if they are the same letter, so OA will be the answer, which is here. Yeah, very good. Just erase. I wonder what is this letter.
This because my teacher says the line has to be like if it's a P, the line is here for small letter, but if it's like this, it's capital P.
Oh, okay, thank you. So to denote small letter, let's say A, right, as a vector, right? Do you need to go through the letter?
No, because P and Q has the long thing.
What do you mean by long thing? The
The
leg,
this,
you call it the leg,
yeah, I
Oh,
guess.
okay, okay, okay. Okay, interesting. Thank you. Xe liên gì á? Xèo à? Hmm. Good. PRB. This.
Oh.
How to prove PRB collinear?
I need to prove that they're parallel. These I need to get the K.
Mm-hmm. Wow.
Right.
They don't look
Yeah,
collinear to me. I mean, they can. I mean, on the if you look at the diagram, they look collinear, but somehow the PB and from PB and PR, right? They don't look collinear to me because, like, if you take out 1/3, you will get 4P here, right? And then
Yeah.
you will get minus 6Q, right? Yes. Right? Then over here doesn't look very good. Oh, okay. OB is your way of doing PB. Let me see. Your way of doing PB should be okay. So PB is equal to PB is here, right?
Yeah.
Okay. One way is to use this OP plus PB is equal to OB, right?
Yeah.
OB is equal to 4Q, right? So PB is what you need to find. OP is P, right? So in a way, PB is equal to 4Q minus P. Okay. So one way is to do this.
So that's what I got.
Yeah. But somehow, if you look at this, I don't see how you can get it into a equation with the factor K. So or maybe we should look at the PR here. Okay, let's PAAR. Okay, no problem. PA, where's PA? Where do you get the PA from? 1/3 P.
The question
Over here.
is this.
Is it here?
What does it say? OP equals to third OA. So.
Wait, so OP is 2/3 of OA, right?
Yeah, so P.
Oh, wait, 2/3 of, okay. So that means this is P, right?
So OA is Q over 2P, and then
so
P
OA is P divided by that, so it's flip. So 1.5 P, right?
Yeah.
So OA is 1.5 P.
Minus by 1.
How do you get
wait.
1/3 P then?
Why is it 1.5?
You flip it, it's 3 over 2, right?
Yeah. Oh wait.
Okay. So that means this whole thing OA is 1.5.
Oh, it's 1 over 2.
This is 1.5 P, right?
Yeah.
So how do you get 1/3 P?
Oh, it should be half.
Why half? Yeah, it should be half because
Minus
this is
by
1.
1.
Yeah, this is 1 P. So it should be 0.5. Yeah. So it's half, yes. Okay? Yeah, so it should be 1 over 2 here. Yeah. Right?
Yeah.
Yeah, okay, good. So not right. So you need to redo here, right? Okay, I think right now it should look good. So you take out half.
3. Wait, should I take out half? 3p minus 4q.
Okay, hold on. Let me just double check your AR. How do you get AR?
Oh, wait.
AR.
AR.
AR is this, right?
Yeah, it's because it says SA is equals to 3SR.
Okay, so SA, where's SA? SA is the whole thing. It's the whole thing.
1, 2, 3.
So 3SR. So that means you break it up into 3 parts, right?
Yeah.
So what is your... I don't understand this part. 2/3. What is this?
It's 2/3 of the whole SA. And I already got SA in the first part.
Okay, this is your SA. This is your SA.
Yeah.
Wait. SA is... Okay. SA means this direction, huh?
Yeah.
But AR is this direction.
Alright.
Yes. So... Oh. Okay, so SA is this. So just write it clearly. So you need to get to AS because AR and AS is same direction. So you need to minus. So that means you get 3Q minus 3 over 2P. Okay? And then AR is, like you say, is 2/3 of this thing.
Okay.
Does it make sense?
Yeah.
Okay, so you get 2Q, then P, right?
Yeah.
Yes. So that's your AR. Means this whole thing will be replaced by this. So half P plus, yes, this whole thing. Yeah. Yes.
Q minus half P.
Half P plus 2Q, yeah. Right? Then you take out half. Then you get P 4Q, right?
Wait. Half P minus P should negative half P, right?
Oh yeah, minus, yeah. Yeah, minus. Okay, so you need to look at the... Okay, so PB is 4Q. So basically you put the Q first, because later it's good for you to... so you take out negative half, so you get negative 4Q plus...
Wait, can't you just leave the negative in, then it will just be 4Q minus P, right?
Oh, okay, that's also fine. Yep. Yeah, I try to match this. Yeah, I was trying to match this. Okay.
So the K is half.
Yes, correct. So you can actually use this one divide by this one, and then there is a factor of a factor of half, and then they start from the same point P, right?
Yeah.
Yeah, good. So that's how you show that they're collinear. Okay, so by going through this example, I think you have to be really careful about the direction. Number one, the direction, right?
Okay. Yeah.
And yeah, but so in a way, right? If you need to prove the collinearity, if you make a mistakes along the way, you can't prove the collinearity in the end.
Okay.
So that means, in a way, right? If you cannot prove, that means basically you cannot prove the collinearity. That means somewhere along the way you are wrong. So it's also a good thing, right? It's a good thing that if you can prove, that means whatever you have done previously is correct.
Yeah.
Yeah. So it's a good thing to have this kind of question, right? And you can check, and you can be sure that you get the correct answer before you submit your paper. Okay. So let's try out the part C, which is the more interesting one, I would say. So for the area ratio, mainly two approaches. Number one, same height, and the other, or common height.
Yeah.
Means they share the same common height. Then the other one is length ratio, area ratio, right?
Yeah.
Yeah. Actually, there is one more lah. That one is called unit.
Oh.
Yeah. APR ARB. Oh, that means you need to insert a line here, right?
Oh, well.
No.
Oh yeah, this one here
Yeah.
on the diagram.
Yeah.
PR over RB. Wait, don't I have PR? No.
So yes, different base but common height.
Okay.
Probably somewhere here, common height. So for me, I always like to for the common height question, I always like to extract the APR out and extract the triangles out. Because once I extract the triangle out, it looks easier ma.
Okay.
So A, and then you have this P, then you have the R in the middle, and you have the B. So you extract them out. So once you extract them out, you start to see that, hey, they have a common height here, right?
Yeah. Wait, do we already have RB?
This one, right?
Yeah.
Then after that, what you do is you just do like, this is the common height. Okay, so you just use PR. That's the
Over
base
RB.
times the height, then half, right? Then will give you the area of this. So this will be the area of triangle APR. Alright?
Yeah.
Then you half times RB times the common height, which is here. Then it will be equal to area of triangle ARB, right?
Yeah.
And that's what you want, right? Okay.
Yeah.
APR, ARB, yeah, correct. So HH cancel, half cancel, so it's just PR over RB. Okay?
Yeah.
And PR is this whole thing. Then RB is, do you have RB?
I don't think we have RB.
But I think just now we just proved that what PR is. Okay, so just now you use what PR over the PB, right? Yes. So it's half of this, right?
Yeah.
Yeah.
So it's twice.
So twice. So that means this is 1 unit. This is also 1 unit. Okay. So PR and RB 1 to 1, right?
Yeah.
Okay. Okay.
Okay.
Next, RSB. Let me just erase the RSB. Okay, so I need to extend this. RSB, this one. Compared to APR. This one. How?
Using unit.
Oh, how?
It's wait. Define SRB to SAB.
SRB and SAB.
Because they have common height.
Which one is the base? Given the common height.
AS.
Can you label the common height?
The common height would be here.
Alright, okay, very good. Yes.
And then find APR and APB.
Yeah.
Common height here.
Yeah, yes.
Then find the ratio of the this and this, this and this. Then make it common. Then you find the two.
Okay. So, okay. This one is like, instead of unit, right? Actually, it's unit plus there is a reference figure.
Okay.
Okay. So, let me just walk you through. Let me just erase some of the stuff here. Let me just walk you through. I think this is a very interesting question. Yeah. So actually, the third, I mean, this more than 3 approaches. More than 2. Sorry. So 3 approaches. So the last approach is the unit plus there is a reference figure. So we figure out this is 1 and then this is 1, right? Okay. So in a way, somehow you can get this already. This is 1 unit, this is 1 unit, right?
Yeah.
So now what you need to do is you need to compare your this A R B.
They already give it, I think.
And then
Yeah,
compare your ARB to this RSB. And I totally agree with you, they have common height here. Right?
Yeah.
Okay, so if there's a common height, so basically you are looking at this base and this base, right?
Yeah.
So triangle ARB to triangle SRB is half times base times height is half times base times height. So once again, half and height cancel, right? Right?
Yeah.
So the base for ARB is AR, which is here. And then the base for SRB is this RS. Do you have them?
Yeah, it's two and 1.
Which one is 2? Which one is 1?
AR is 2.
AR is 2, and then this is 1.
1. Yeah.
So okay, so it's 2 to 1, right? Okay? So in a way, right, the area ratio is actually 2 to 1. Okay?
Okay.
Okay, good. So done. So you see? So this is 1, this is 1. But now this is 2, so this has to be 2. And this will be 1. Right? So that's why the RSB is 1. And then your this APR, actually APR and the ARB is the same thing. So it's 1 to 2. Understand?
Okay.
You understand or not?
Yeah.
So in a way, right, there is a reference figure. The reference figure is this reference. This is the reference figure. And we found out the reference figure with respect to this APR just now is 1 to 1, right? From your this one. Right?
Yeah.
Just now is 1 to 1, right? And
Yeah.
now this one, okay, let me use a different color. This one is 2 to 1. Okay? Understand me now? So right now you need to this is 1, this is 2, so somehow you need to get it into So you need to kind of like, if you have 1 to 1, and then let's say P to A is 1 to 1, and then now you have A to B is 2 to 1, and then so somehow you need to make the unit for A common. So you times 2 here, so it's 2. So the unit A is common already, so this one is 2. So therefore P to B is 2 to 1. Does it make sense?
Yeah.
So in a way this is 2, and this is 1. So 2 to 1. Yeah. Or 1 to 2. Yeah. It depends which one you put it above. Okay?
Okay.
Very simple, huh? So yeah, so the third approach will be unit plus a reference figure. In this case, the reference figure is this. Okay?
Okay.
Okay, very good. Okay. Oh, so in a way, this is a very interesting question, and I will. Sorry, I think this question is a very likely candidate for your exam later on. Okay? Something similar lah. You expect something similar. Okay?
Okay.
Yeah. So this is how many points for this question? 1, 2, 3, 4, 5, 6. Like about at least 8 points 8 marks. Questions like this, 8 marks. Okay?
Okay.
So close to 2 grades. Okay, 1 grade is 5 marks. Yeah.
Yeah.
Okay, good. Okay, so okay, we can actually take a break, then we can come back later.
Okay.
Okay? So see you later on.
Okay.
After the break.
Okay.